Machine learning is a powerful tool. It allows computers to learn from data, and this is done without explicit programming. Imagine a computer program that learns to identify cats in pictures. It does this by analyzing thousands of images. Some images have cats, while others don't. The program learns the patterns associated with cats. This learning process is the essence of machine learning. Machine learning is used in many applications today. It helps us filter spam emails. It recommends products we might like. It even powers self-driving cars. The possibilities are endless. As more data becomes available, machine learning algorithms become even better. This opens up exciting opportunities for solving complex problems. There are different types of machine learning. One type is called supervised learning. In supervised learning, the algorithm learns from labeled data. This means each data point is tagged with the correct output. For example, in the cat picture example, each image is labeled as cat or not cat. This labeled data helps the algorithm understand the relationship between the input, which are the images, and the output, which is whether it's a cat or not. Another type of machine learning is unsupervised learning. In unsupervised learning, the algorithm is given unlabeled data. It must find patterns and relationships on its own. This is like giving someone a puzzle without the picture on the box. They have to figure out how the pieces fit together. Supervised learning is like having a teacher. The teacher provides examples and the student learns from them. There are two main types of supervised learning: classification and regression. Classification is used to predict a category or class. For example, predicting whether an email is spam or not spam is a classification task. Another example is classifying images of handwritten digits. The algorithm learns to distinguish between the different digits 0 to 9. Regression is used to predict a continuous value. For example, predicting the price of a house based on its features like size and location is a regression task. Another example is predicting the temperature tomorrow based on historical weather data. Regression models are useful for making predictions about numerical values. Within classification, there are different subtypes. Binary classification involves predicting between two classes, like spam or not spam. Multi-class classification involves predicting between more than two classes. An example is classifying an image as a cat, dog, or bird. Before we can train a machine learning model, we need to represent the data in a way that the computer can understand. This is where data representation comes in. One way to represent data is using features. Features are measurable properties or characteristics of the data. For example, in the house price prediction example, features could include the size of the house, the number of bedrooms, and the location. These features are then used to train the model. Another important concept is one-hot encoding. This technique is used to represent categorical data, such as colors or countries. In one-hot encoding, each category is represented by a binary vector. This vector has a 1 in the position corresponding to the category and zeros elsewhere. The model training process involves feeding the model with the prepared data. This data is split into training and testing sets. The training set is used to train the model. The testing set is used to evaluate its performance. During training, the model learns to map the input features to the output labels. Loss functions are used to measure the model's error during training. The goal is to minimize this error. Precision and recall are metrics used to evaluate the performance of classification models. The k-nearest neighbors, or KNN algorithm, is a simple but powerful algorithm used for both classification and regression. It works by finding the k-nearest neighbors to a given data point and making a prediction based on the majority class for classification or the average value for regression of its neighbors. Understanding machine learning is becoming increasingly important. It empowers us to solve real-world problems. These problems range from disease prediction to personalized recommendations. By grasping the basics of machine learning algorithms, data representation, and the training process, we can unlock its potential to make informed decisions in various fields.